Hi, I'm Surya. Today, here to tell about what is the role of alpha in machine learning and how to ensure the robustness of a model using the f value, p value, and the r squared value. Okay, now let's go to the presentation. Okay, first, what's the role of alpha in learning? Alpha is none other than the learning parameter which is used to set up gradient descent to get the desired outcome from a machine learning model. Alpha is set amount of change in the coefficients on each update. That is, it determines how big the step would be on each iteration. If alpha is very small, it will take smaller steps, and likewise, if it is very big, it will take larger steps. If it takes smaller steps, it will take longer time to make a coverage, and it will become computationally expensive. Whereas if we take larger steps, it would take a minimum time to make a large coverage, but it would sometimes miss the required coverage. That is, for an example, let's take a graph which is constructed based on a learning model. Now, in y coordinates, we see the cost, and in x coordinates, we see the number of iterations. Like we see, the blue line represents the smallest value of alpha, like 0.01. For this alpha value, the cost function decreases slowly as we go from number of iterations increases. It also tells us that a slow coverage during gradient descent. Also, if you notice, 1.3 is the largest learning rate, but alpha value equal to 1 is the fastest coverage rate. You can see that we can see that if after a certain point, if the alpha value is reached, even if we increase the alpha value, there will be no difference in the coverage of the machine model. Next, we are going to see about how to ensure the robustness. First, what is R squared value? That is, if the greater the R squared value, the better the model. The highest R squared value represents smaller difference between observed data and the fitted data. That is, an R square of 60% reveals that 60% of the data fits the regression model. How well the regression model fits the observed data is measured by R square value. Practically, there is no regression model with an R square value of 100%. In such case, all data points would fall exactly on the regression line. But such regression line doesn't exist. Next, we are going to see about p-value. P-value is a statistical test that determines the probability of extreme results of the statistical hypothesis test. That is, if the smaller the p-value, the stronger the evidence that you should reject the test hypothesis. If the p-value is less than the significance level, that is usually 0.05%, that is 5%, then your model fits the data well. Next, we are going to see is F value. F value is mostly used when comparing models that have been fitted to a data set in order to identify the model that best fits the population from which the data were sampled. Higher the value of F, the better the model. Therefore, from this, we can conclude that to ensure the robustness of a model, the model should have a greater R square value, the model should have a smaller p value, and it should have a greater F value. That is, the greater the R square value, which says that there is a small difference between the observed and the fitted data, and the p value should be smaller, that is below 5%, so that we can reject the null hypothesis or the test hypothesis. And F value is used when comparing models that have been fitted to a data set and should have a greater value. From this, we can ensure the robustness of a devised model. Thank you.